Sir, Lokesh, sir?
LOKESH sir has joined her.
Yes, sir, I think sir has joined.
Yeah. Good morning, sir. Good morning,
Good
LOKESH
morning,
sir.
sir.
This is Dr. Rajan. Hello.
Yeah, good morning, sir. Can you see me?
Very, very good morning. I am able to see you now.
Yeah,
Good
yeah.
morning.
Good
How are you,
morning,
sir?
sir.
Good
Yeah,
morning.
if everybody, do you want to wait and start, or madam, have people have left somebody? I saw two people earlier. Or is
Yeah,
it
sir,
just
I think only few members has left.
yeah.
So if you want, means we can wait for 5 minutes, sir.
Yes,
So
sir.
that
We
at
wait for 5 minutes.
11:20.
Shall we wait for 5 minutes and start, sir?
No issue, sir. No issue.
Okay. Thank you. Thank you.
Fine,
How
sir.
is the workshop going on, sir?
Yeah, it's successfully going on. Today, the fourth day, only we have strength is a little bit low because exams are going on, advanced exams are going on. So local faculty, that is in Chennai, people are
Okay.
busy with their exams. Otherwise, the
Okay.
strength would be not less than 75, 80. So today only the
Yeah.
strength is a little bit less. Sorry
Sure.
for that.
No issue. No issue. No issue. I can understand.
Yeah.
And nowadays, it is so that there are a lot of webinars being hosted online.
Yeah.
People tend to attend most of the time on webinars only.
Yeah. And the thing is, these exams are also now being conducted through online only. So,
Oh, okay. Okay.
yeah, this lab, even the practical exams are now going on through online. So there's a challenge for all the faculty. They have to do everything through online, like examination, demonstration of the laboratory, all virtual. So it is. So in
Yeah.
between, this seminar is also there. This
Okay.
be also.
So
Thank you a lot, sir.
all the other slots are totally booked, or is there any slots in the next one day it is open, something like that?
Yeah, still, sir, still after you, Mr. Jaishankar sir is giving from Ultratech, and then tomorrow, oh, you want, yeah, for any reason you are asking, like, you
I
want to give,
thought, I thought, in fact, I did discuss with Jaishankar sir also.
okay, sir.
I wanted to know what are the issues that he is going to cover.
Okay,
So Jaishankar sir told he will discuss on quality control issues.
yeah,
So I will discuss more on designs today, so that in the
okay,
later half of the day, probably will take up quality control. Okay. If
okay.
any missing whites are there, please let me know. I can take on some class for quality control also.
Definitely, sir, definitely.
So
I
that
will let you know, sir. I'll
yeah,
let you know.
yeah, it will be useful for the attendees.
Participants, yeah, definitely, sir. We'll do that. Okay,
Yeah.
sir. Thank you. Thanks a lot.
Yeah.
Another 5 minutes, you can start, sir. Thanks a
No
lot, sir.
issue. No
You
issue.
can slide share and keep things ready if you want. Like,
Yeah, that can be done. No issue.
okay.
Yeah, sir. Fine, sir. It's visible, sir.
Yeah. Okay.
Yeah, fine. Sir, one more suggestion, sir. Can you please click the hide icon so that
Yeah.
yeah,
I did.
fine. Yeah, sir. Fine. So once again, welcome you for day 4, session 2 of SCTP program. So I welcome Mr. Lokesh Tia, sir, who has been working as an executive director and infra support engineering consultant private limited, Bangalore. He has over 20 years of rich experience in the field of civil engineering with interest in infrastructure, road and construction supervision, project management, and payment engineering. His expertise is in the area of payment design and design of all categories of roads, infrastructure design for township, layouts, SEZs, and providing of field solutions. He has coordinated several projects that involve preparation of feasibility studies, detailed engineering design, and drawings for major highways and express projects and transportation hubs. His expertise is in the area of white topping design and supervision of white topping roads for the city of Bangalore. Most of these projects are funded by either funding agents like World Bank, ADB, or national and state governments or private developers. So he has done his ME in highway engineering in 2001 and B in as a civil engineering in 1998. And currently he is a life member of Indian Road Congress (IRC) and a life member of Indian Concrete Institute (ICI). I welcome you, sir. I'll just hand over the session to Engineer Lokesh, sir, who's going to deliver his lecture on the topic concrete payment for highways, design, construction, and quality control as per IRC 58.
Yeah, thank you. Thank you, madam, for the introduction. So, good morning, all. Today, we are going to discuss on the designs, what are the parameters that help us in designing the rigid pavement or CC pavement for as per IRC 58 for roads such as state highways, national highways, as well as expressways, basically. So IRC 58 2015 was first schedules. IRC code was first given by Indian Roads Congress in the year 1974. Later on, currently we are having the latest revision IRC 58 2015. The biggest difference between earlier version and this version is we are having a laden commercial vehicle weight varying from 8.1 to 10.2 tons. So this will be my presentation structure for the day. We will know what are the different types of pavement in the introduction and what are the different type of concrete pavements that a designer can design, and what is the scope of IRC 58 2015, design of rigid pavements as per IRC 58, and we will take up a small case study so that it will be useful for all of us, because IRC 58 along with the code they have also supplied a automated automation Excel sheet where you can input all the required information or design parameters, and you can arrive and check the requirement of the design basically. So when it comes to what are the different types of concrete pavements that a designer has a privilege to work in Indian context, we have plain jointed rigid pavement for highways. The highways can be state highways, national highways, as well as expressways. Continuously reinforced concrete pavement, which is also called as CRCP. Concrete pavement with for low volume roads, and conventional white topping, or probably we also call it as thin and ultra thin white topping. Probably this entire white topping issue will be discussed by my next speaker, Sri Jaishankar sir. So we will just understand what are the various differences upon these type of payments. This is a schematic diagram of the concrete typical cross section of a conventional concrete pavement. Conventional concrete pavement is always placed on a prepared subgrade. which is an earth material, followed by a granular subbase material. We also call it as GSP, as well as drainage layer. These are the components, various components of a conventional concrete pavement, such as there is an expansion, there is a transverse joint at every 4.5 meters, which is also called as dowel joint. These are the dowel bars provided. There will be a longitudinal joint at a spacing of 3.5 meters, which will run parallel to the center line of the road. So, which makes the pavement a slab, or in general 3.5 by 4.5 as a panel size. It will be, the top surface of the pavement will have a texture. The texture will be either on the longitudinal direction or in the transverse direction, as shown here. In most of the Indian roads, you can see the texture in transverse direction, but in abroads, we can see some of the roads with longitudinal texturing. The thickness generally of concrete pavement, which is designed as per IRC 58, will vary between 150 mm or 200 mm to up to 350 mm. 350 mm basically. The grade of concrete generally that is used for pavement concrete is minimum grade is M30. It can go maximum up to M50, M60, but in all the given possibility, M40 is the PQC, pavement quality concrete, that will be always adopted. So this is one such diagram of continuously reinforced concrete pavement. The difference between continuously reinforced concrete pavement as well as the conventional pavement is you are going to have a reinforcement in the both longitudinal as well as reinforced concrete for the reinforced concrete pavement. Continuously reinforced concrete pavement, the reinforcement will be provided on both longitudinal as well as transverse reinforcement. This reinforcement will always have a reduction in the pavement thickness. All other parameters which go with respect to conventional pavement will remain as it is, like that of pavement quality concrete, as well as texturing, everything. The only difference is in providing the transverse and longitudinal reinforcement, there will be a reduction of pavement thickness. This is a conventional photograph showing the white topping. White topping can be simply mentioned that it is a concrete overlay on the existing flexible pavement. Generally the size of concrete white topped pavement for panels will vary from 0.6 to 1.2 meters. There will not be any dowel bars, but tie bar is the requirement decided based on the width and the width of the carriageway. Generally, the thickness of concrete overlay on the existing bituminous surface will vary between 150 mm to 200 mm. The only this thing is we are supposed to ascertain the existing strength of the flexible pavement, then remove the functional failures such as light cracks that are on surface of flexible pavement by a process of milling, then go with the concrete overlay. Concrete overlay, once again, the pavement quality concrete remains as M40 or minimum grade is M30. So these are the various codes that are available for us for the design of concrete pavement, like IRC 58 2015 guidelines for the design of plain and jointed rigid pavement. IRC 118 will help us in understanding the design guidelines for continuously reinforced concrete pavement. Low volume roads can be designed using IRC SP 62 2014. And white topping design will be can be carried out using IRC SP 76 2015. So when it comes to what are the scopes that has been covered in IRC 58 2015, as I told, IRC 58 2015 is the design of plain jointed concrete pavement with and without tied concrete shoulders. This is applicable for the road where the commercial vehicles per day is more than 450. And commercial vehicles, when I mean individual vehicle weighing more than 3 tons. So when it comes to the concrete pavement, There are several types of concrete pavements can be designed depending upon the climate, availability of material, soil type, and the experience that a designer has. But in this photograph, in this slide, you can see the two different pavement compositions. Here, the subgrade remains same for the both. Second, GSB granular subbase remains same. The variation will be there with respect to dryling concrete, which is a cemented subbase. Here, it is a cement-rated material or cement-rated aggregates. Then, both the cross sections shown here are debonding material. In one cross section, you can see 125 micron polyethylene sheet as a debonding material. In other case, bituminous concrete of thickness 30 mm to 40 mm can also be considered as a debonding material. Once again, as I told you, the economy of the pavement design is all the more important. So depending upon the cost, the suitability of the materials that can be used for a debonding material can be varied. So what are the factors that govern for the design of a rigid pavement? First one is the design period, design commercial vehicles, composition of traffic in terms of single, tandem, as well as tridem, multi-axle, axial load spectrum, tire pressure, lateral placement characteristics, directional distribution, strength of foundation, climatic conditions. So these are the factors that govern the design of rigid pavement. Let us see individual parameter. Design life. Generally, the concrete pavements, unlike the flexible pavement, which is designed for 15 years design period, concrete pavements are designed for a span of 30 years. All the more important for us to judge the design period depending upon the traffic volume, uncertainty of traffic growth, capacity of roads, and possibility of widening of the road. Assume if there is an existing road with a two lane having some capacity. If it is to be designed for a concrete pavement of 10-meter width, as far as IRC 73 concerned, the minimum width of carriageway for a two-lane is 10 meters with 1.5 meters as paved shoulders. Considering it as 10 meters, if you decide to go with a concrete pavement for a two-lane, if based on capacity, if it warrants a 4-lane in the next 5 years or less than 10 years, then it would be difficult for us to convert the bi-camber into a unidirectional camber, which is given for a 4-lane road. Thus, it is all the more important to assess the traffic volume, traffic growth, as well as widening that is going to happen in the next 15 to 30 years. Then, it is important to understand the design lane for the design. When it comes to IRC 58 designs for a two-lane road, the two lanes are considered as a design lane, whereas for the 4-lane or multi-lane, outer lane of the pavement is considered as the design lane. The matter in case of 4-lane and multi-lane, the outer lane is considered because it is always expected that the heavy traffics will take the outer lane and the faster moving vehicles will take the inner lane. So it is important for us to study the traffic studies based for 7 days, 24 hours as per IRC 9. The traffic studies shall be carried out classified volume in both the directions. Then, as I mentioned, traffic growth rate is an important parameter in deciding the base traffic as well as projected traffic for the next 30 years. As per IRC 84, which is a codal provision for the design of 4-lane highway, 5% is the growth rate that is recommended, which can be also be determined using appropriate methods. Traffic count is required to be carried out both in day as well as in night, because day traffic will be responsible for bottom-up tracking, whereas night traffic will be responsible for top-down tracking. So this is a standard format generally that we follow in the site to conduct the traffic volume studies. Each row will accommodate 15 minutes count. So each sheet will accommodate 1 hour traffic count. Here the project name should be written. From direction and to direction shall be noted here, and date and name of the person who enumerates during the period. Here you can find all different categories of vehicles that should be counted, which is also that is the reason it is called classified volume count. So these are the various categories of vehicle. Some of the vehicles will not have any role to play in the design of rigid pavement, but at the same time, these are the categories of vehicle which helps us in understanding the capacity of the road. Whereas those vehicles which are more than 3 tons, specifically buses, 2-axle, 3-axle, and multi-axle trucks, will definitely contribute their presence in the design of concrete pavement. So this is how the formats will be filled in the site, wherein for every 15 minutes the count will be summarized, and for 1 hour we are going to summarize the data. So these are some of the photographs which shows how the arrangements will be made. And other important survey that has to taken care during the traffic survey is the origin and destination survey. Origin and destination survey generally will help us in arriving the growth factor for the period. Generally, roadside interview method will be followed in conducting origin destination survey, where a series of questions will be asked to the driver, like what is the duration, what is the frequency in which the vehicle he will uses this road, what is the commodity, from where he is coming, and from where it will be delivered, what is his duration of utilizing this our facility. So like this, a series of questionnaires will be done. Those data will also be useful for us to analyze the OD matrix as well as OD zoning, from which we can arrive the growth factor. Then coming back to lane displacement characteristics, it is something like when a loaded truck moves towards the edge of the pavement, the structural stresses caused by the axial load at the bottom for bottom-up cracking will be much higher. So it is always advisable to keep the vehicle at least 150 mm above the longitudinal edge, so that the stresses at the edge get reduces. That is the reason even when we design the pavement, after which we are going to design the dowel bars, the first dowel bar is kept at a distance of 150 mm from the edge, so that the edge flexural stresses are reduced. For the design consideration, as per IRC 58, for 2-lane, 25% of the total vehicles, commercial vehicles on both the directions are considered. Whereas in case of 4-lane and multi-lane design of rigid pavement, 25% of the total traffic, which is predominant on the directional movement, is considered for the design. Then coming back to the design parameters, top-down cracking. The design traffic for the top-down fraction, top-down cracking is a fraction of the design considered for bottom-up cracking. Only those vehicles having the space between front axle and the rear axle more than 4.5%, it's a single axle truck for that matter, will be considered. As per as IRC 58 is concerned, the default value of 50% for the design of bottom-up cracking analysis can be considered. Then other important parameter that works out to understand is to find out the expected number of repetitions in terms of MSA. Though this does not play a very vital role in the design of rigid pavement, it is important to back calculate and check what will be the front axle weight that is going to have taken case in case of bottom-up fatting damage. When it comes to axle load survey, though the legal axle weight for single, tandem, and tridem vehicle is around 10.2 and 19 and 24 tons, it is always observed, and it is seen in the site that the vehicles are being loaded in the much higher than the legal limits. So it is important for us to bring these axle loads from the site, and that will form as a input for the design of rigid pavement. So in order to do so, we are supposed to carry out an survey called axial load survey. In this axial load survey, the sample size, if the commercial vehicles are more than 60,000 CVPD per day, the sample size shall be 10%. Sample size of 15% shall be considered for CVPD more than 3,000. Then the sample size of 20% shall be considered if the vehicle commercial vehicles per day is less than 3,000. The duration of the survey, generally it should be 48 hours. And at the same time, the tire pressure is also an important parameter, which will vary from 0.7 MPa to 1 MPa, whereas for the design, we take around 0.8 MPa. But when the concrete pavement is designed for a thickness just above 200, the significance or the effect of tire pressure is much negligible. So this is an arrangement where we can understand how the axial load survey will be done. So this will be an digitally attached, you can see a wire which will be attached to a digital indicator. This is called a weighing pad. This will be placed close adjacent to the edge of the existing road shoulder. Each vehicles are allowed, one axle, one wheel is allowed to pass through this pad. We are going to measure similarly all the wheels of the axle. You can see this. Then it is multiplied by 2 to get the axial load weight. Once the axial load weight is calculated is obtained from the survey data of 48 hours, we are going to have a matrix showing the single axle weight varying from 18.5 tons to 19.5 down less than 8.5 tons. We are going to have a bifurcation of what is the percentage or frequency in which we are going to have the data. Once this data is done, this will be used as an input for the design of rigid pavement. Then the two critical stresses that will be considered for the design of rigid pavement is bottom-up cracking as well as top-down cracking. Bottom-up cracking occurs during the daytime. The flexural stress at the bottom layer of concrete slab is maximum during the day when the axial load will be acting on top, due to which the beam tend to sag, which protrudes a crack from the bottom. Whereas in the top down, there will be a variation in the temperature with respect to more night top as well as with the bottom in the night, where the temperature will be cooler at the top, whereas bottom it will be a bit high. Then there is a chances that the slab get crawl. Though we have provided the dowel bars as well as the tie bars, it tends to crawl, which is defined as top-down cracking. For the top-down fatigue cracking analysis, it is all the more important for us to study what is the spacing between the first wheel as well as the first axle and the rear axle, and what is the difference with respect to the length of the panel. Generally 3.5 by 4.5 is the panel that we will consider for the design. In all the cases, the wheelbase of the trucks will vary from 3.6 to 5 meters. Those axles which are more than 4.5 meters will not contribute much to top-down cracking, as there will be a dispersion of load on the two slabs. Then the other important parameter in the design of concrete pavement is temperature control, temperature issue, because most of the time the concrete pavement will have an impact of temperature. The temperature difference between the top and bottom fibers of concrete pavement causes slabs to curl. The reason for the various reason for temperature difference is due to solar radiation that is received by the pavement surface, wind velocity, latitude and longitude are the location of the pavement where it is placed, elevation of the location, and all the geographical features of the location. So for the design purpose, when it is difficult for us to measure all the parameters which I just discussed, to consider it in the design, as per IRC 58, it is recommended for various thickness of the pavement for the various region in India. We can have the difference of temperature given in the table, and considering the state in which the project is taken up for the thickness for which the pavement is designed, the variation in the temperature can be considered for the design straight away. So it is ideal that there will be a variation in the temperature on the daily basis as well as hourly basis. So IRC specifies, in order to check the variation in the temperature, 6 hours in a day and 6 hours in the night shall be considered for the design. 6 hours from 10 a.m. to 4 p.m. is the daytime that we mention it as stopped during the day stresses, and during the night it can be between 1 a.m. to 6 a.m. in the night. So remaining portion during the remaining period, the slab is allowed to crawl for the purpose of analyzing the fatigue damage. Then there is something called zero stress temperature gradient. Concrete pavements are always being laid during the night. The slabs laid in the night and early morning will have a positive temperature gradient due to the solar radiation as well as chemical reaction that happens within the concrete. When there is a positive difference of temperature, it remains flat because it is in the process of hardening. The condition where the higher temperature on the top of the surface and lower temperature on the bottom fibers is termed as zero stress temperature gradient. Then the another important parameter that plays a vital role in the design of concrete pavement is the subgrade strength. Subgrade strength, when it comes to it is required to analyze what is the effective CBR of the subgrade. When we are analyzing the effective CBR of the subgrade, it is important to analyze what is the existing CBR of the OGL sample, then what is the expected borrow material that the OGL sample, the borrow material that we can get the CBR. Knowing these two values, we can arrive at what is the effective CBR. In turn, we can also calculate what is the modulus of subgrade reaction of soil, which is K, for the subgrade. Assuming you are having a CBR of OGL around 7%, then we are going to have a borrow material of 500 mm thickness, where we are going to have a 12 or 13 or 14 for that matter for the CBR of borrow material. Just come across here, find out what is the effective CBR. It will be around 12. Considering 12 as effective CBR, the K of subgrade can be arrived. The other important thing is nowadays, now we can also find out the effective CBR using IIT-PAVE, which is explained in IRC 37/2018. Then coming back to subgrade material can be a native soil. Like if you get a good soil at OGL level, it can be used as a subgrade material. It can also be used as a borrow material. It can also be a borrow material. The only thing, the requirement of subgrade will be of that of 1.5 density of 1.75 gram per cc. CBR shall be as per the design requirement. It is important to find out the K value conducting the plate load test. So in all the possibility, as per IRC 58, in order to analyze the foundation is assumed to be a Winkler foundation, whereas you can see in this diagram the difference between a Winkler foundation as well as the elastic foundation. Since the K value is an important parameter for the design of rigid pavement, which is to be tested and obtained from plate load test, which is time consuming as well as very expensive. IRC 58 also gives us to know the K value from the CBR California bearing ratio, which is a 4-day soaked CBR test. Based on the 4-day soaked CBR test, we can finalize, we can know what is the K value. Say if our effective CBR, if our effective obtained borrow earth is having a CBR of 10%, then our K value will be 55 MPa. Similarly, when it comes to granular base as well as cement treated base below the PQC, it can be a cement treated or it can be a untreated granular base, which can also act as a subbase layer below the PQC. Depending upon the thickness, the K values can be considered from IRC 58. When you are using a dry-lean concrete of 100 mm thick as well as 150 mm thick, for the varying K values, the effective K value of DLC of 200, say 200 up to 200 could be used depending upon the CBR value in the design. When in the initial first slide where I was mentioning that separation membrane, as I just mentioned, separation membrane can be either a polyethylene membrane or a bituminous concrete with for 30 mm or 40 mm, or even a wax-based compound can also be treated as a debonding layer or separation member. The interface between the concrete slab and the dry-lean concrete to be provided as smooth to reduce inter-layer friction. Allow the relative movement of slab and DLC layer. Pavement reflects cracks in the slabs. Debonding interlayer can be 125 micron polyethylene sheet. Then comes the concrete strength. Flexural strength of concrete is required for the design of concrete pavement. When it comes to flexural strength of concrete, it can be obtained using concrete by casting concrete cubes and checking the cubes for its strength. IRC 456-2000 will help us in deriving the characteristic flexural strength from characteristic cube compressive strength, that is 0.7 root FCK, where FCK is the grade of concrete or characteristic strength of concrete that we are going to take. If we are going with an M40 grade concrete, FCK will be 40. So 40 root 0.7 will give us the flexural strength of concrete. So in all possibility, the flexural strength of concrete for a PQC of M40 grade is considered as 4.5 MPa. Whereas when it comes to flexural strength, it is all the more important for us to find out flexural strength with respect to target mean strength, which can be arrived using the formula. The important parameters that also count is the material property of concrete, that is elastic modulus as well as Poisson's ratio. As the elastic modulus increases, the Poisson's ratio decreases. Elastic modulus is a parameter which is dependent on the grade of concrete. If PQC of M40 is used, the E value can be 30,000 MPa. If the variation in the grade of concrete is done, it can be calculated using an equation 5000 root FCK. When other parameter in the design that goes is the thermal expansion, which is lambda. Generally, the coefficient of thermal expansion of concrete is dependent greatly on the type of aggregates that we use in the concrete. For the design purpose, as per IRC 58, 10 into 10 power of -6 could be adopted. Fatigue behavior of concrete pavement. So due to the repetition of application of flexural stress by the traffic movement, there is a fatigue damage that is caused on the concrete surface, which is a micro crack, which can be in the form of micro cracks. The ratio between the flexural strength applied to the flexural strength of concrete is called stress ratio. It is always felt that if the ratio between applied stresses and the flexural stress is less than 0.45, it will have much fatigue life. So whenever we design a flexible pavement, rigid pavement with the various parameters considered, it is always advisable to keep additional 10 mm for additional 10 mm for the concrete pavement increase for retexturing in the next 30 years. So computation of flexural strength. These are the various computations that should be checked using IIT rigid, wherein we are going to place a single axle on a panel of 3.5 by 4.5, then a tandem, then as well as tridem axle vehicles. Similarly, whole vehicle is placed on one slab. Possibility of placing that with respect to the dimension of the vehicles. We are going to analyze the stress calculations. So stress calculations are analyzed for bottom-up cracking with respect to tied concrete shoulders, untied concrete shoulders with single as well as rear, tandem as well as tandem for tied shoulders. For the top-down cracking analysis, the pavement width and without dowel bars can be analyzed for all the set of vehicles. This additional width, what you can see in the drawing, is the additional tight shoulder, what I mean to say. It is observed from our experience that whenever the tight shoulder of 1.5 meter is provided in any category of road, whether it is state highway or a national highway, there will be a reduction in the thickness. So as well as the stresses comes down. For heavy traffic condition, dowel bars are provided across the transverse joint. Tight shoulders are necessary for high volume roads. As I just mentioned, this will reduce the thickness of PQC. The traffic less than 450 mm, it is not required to provide any tie bars. Of course, traffic less than 450 commercial vehicles, we need not go with IRC 58 design. It can be a different design as I discussed earlier. Then the terminal load transfer efficiency values of 60% for dowel as well as 50% for tie joints. Then comes an issue of fatigue damage analysis. So what is fatigue? Fatigue is always abbreviated as NF, is the number of stress cycles of a specified character that a specimen sustains before the failure of before the failure. Generally, the cumulative fatigue damage for bottom-up cracking and cumulative fatigue damage for top-down cracking should be less than 1 for the safe design. So this is one slide where it will help us in understanding what are the considerations that should be done. A flowchart type of thing where you are going to consider the design parameters. You are going to assume a trial thickness. You are going to calculate the computations of repetitions that are going to play. Provide the axial load data. Then considering the 6 hours night and 6 hours day, we are going to calculate bottom-up cracking as well as top-down cracking for the analysis. Compute the flexural strengths and then go with the check for the fatigue. If it is less than 1%, less than 1, automatically the design is safe. So this is the standard pavement design sheets that are been provided by IRC, wherein we can always input the data, what type of road it is, a 2-lane paved shoulder or 4-lane paved shoulder, and category of road, whether we wanted to have a tied joint or untied joint. Generally, the transverse spacing of 4.5 to 3.5 meters. Transverse joint, whether we are providing a dowel bar or not, design life of 30. Modulus of subgrade reaction, as I discussed, we can input the data. Thickness of granular subbase. Granular subbase will also act as a drainage layer in case of concrete pavement. Drilling concrete thickness of 150 mm. Considering this as 150 mm, we can find out what is the effective subgrade reaction. Then unit weight of concrete. What is the unit weight of concrete? Flexural strength, as I mentioned, as long as we are using M40 grade of concrete, it can be 4.5 MPa. Then temperature difference, depending upon the zone in which we are working, we can take it from the table. So two-way commercial, what is the commercial vehicles that we are going to have? Growth rate of 5%, which I mentioned, can be inputted. Then these are the various parameters that that should be included. Then propose a trial thickness of 0.66 and then check what are the effect of fatigue as well as this thing. You can see this is the axial load data that is getting inside from the axial load survey data. So with this, we can cross check what is our fatigue damage that is coming. This is a simple Excel file. Once you input all the required data, it can be included in that. Then coming back to joints, there are three types of joints. One is contraction joint, expansion joint, and longitudinal joint. Contraction joints will be provided at every 4.5 meters, and it will be provided with the dowel bar. Whereas expansion joint, it depends whether it depends on the project site. Generally, expansion joints are provided where there is an existing culvert or binder bridge or major bridge or any structure for that matter. And longitudinal joints are provided at every 3.5 meter with a tie bar. This is a typical section of the joint arrangement, where you can see this is the longitudinal joint with tie bars, and this is the transverse joint with dowel bars. Generally, the tie bars will be around 12 mm diameter, whereas dowel bars will be 25 or 32 mm diameter, which is once again dependent on the design, the pavement thickness. This is similar schematic diagram showing the type of joint, where you can see half portion of dowel bar is painted and other half is unpainted. Each length of dowel bar shall be extended on both the sides for one panel as well as for another panel. On top of the existing groove, we are supposed to go with the sealant compound. When it comes to expansion joint, generally it will be around 20 mm thickness. You can see a filler board will be provided. For the expansion joint, we are going to have a expansion cap, which will allow the pavement to have the movement. Here also, we are going to fill the joint with polyethylene or joint sealing compound. So this is the typical table given by IRC 58, where depending upon the thickness of the pavement, we can design what is the requirement of dowel bar and what will be the length and spacing. Similarly, for varying thickness of the concrete pavement with varying diameter of tie, we can have a tie bar. Tie bar as well as dowel bar can be both MS or TMT. So I will just quickly run through the various quality control issues on concrete pavement. And when it comes to quality control, it can be done in 3 stages. Stage 1, pre-paving activity. Stage 2, plant and mix production. Placement and finishing and curing. So in step 1, it will be a preparation of surface. Then if there are any accommodation of utility ducts, milling will come only in case of white topping. Profile correction and milling both are parameters of white topping this thing. Fabrication of steel shutterings as well as mix design. Plant then step 2 is plant site and mixture preparation. Materials for the concrete mix design will be cement, admixtures, fibers, coarse aggregate, fine aggregate, water and mineral admixtures. And the stages, stage 3 is placing, finishing, texturing, curing and sawing. In this, we will be discussing on spread of concrete, paving operation, finishing, texturing, curing, sawing, and opening to traffic. So, in case of plant and mixed proportion, the material that we are going to use are cement, admixtures, fiber, coarse aggregate, fine aggregate, water, and mineral admixtures. As we all know, the concrete is a mixture of cement, air, cement, water, sand, and aggregates. Generally, the percentage of air in concrete is around 3 to 6%. Cement is around 10 to 12%. Water is around 14 to 18%. Sand is around 20 to 27%, as well as aggregate is around 40 to 45%. So, what are the different types of cement that can be used for production of PQC? It can be OPC of 33 grade, it can be OPC of 43 grade, and it can be OPC of 53 grade. Depending upon the project specific, it can be sulfate resistant, Portland cement, pozzolana based cement, slag cement like GGBS as a partial replacement, rapid hardening cement, and low heat Portland cement. In most of the cases, we are going to use OPC 53 grade cement for production of PQC. So the properties of cement shall be: initial setting time should be 30 minutes, final setting time shall be 600 minutes. Compressive strength of cement for 3 days shall be 23 MPa, whereas for 28 days it shall be 43 MPa. Specific gravity shall be 2.9 to 3, whereas fineness per square meter per square kg shall be 225 minimum requirement. As I told, generally we can use 43 grade and 53 grade cement. In all possibility, the maximum cement can be 450 kgs per cubic meter, whereas for PQC, the minimum grade of cement is specified at 400 kg per cubic meter. So it is important for us to get the manufacturer certificate before start of the work. Once the cement is procured in the site, it is important for us to check the compressive strength as well as setting time. The next important parameter is fine aggregate. Fine aggregate shall be in accordance to IS 2116 and IS 383. Fine aggregate can be a natural sand, crushed stone, or mixture of both. Now, most of the states have banned natural sand mining, so we can definitely go for a manufactured sand or what we call as crushed sand. So these are the various zones of that are available as per IS 456, Zone 1, Zone 2, Zone 3, and Zone 4. The additional information that has been leveraged, that is given for a manufactured sand, is that for a 150 micron passing, additional increase of 20% is permitted as per IS 383 for manufactured sand. So this is one photograph showing the sand with the fineness modulus of 3.08. This is for sand zone 3. You can see the variation in the grading of the sand, and also you can see the feel the value of fineness modulus variation. So in all the possibility, we are going to have a fineness modulus of 2.2 to 2.6 for fine sand, for 2.6 to 2.9 for medium sand, and 2.9 to 3.2 for coarse sand. And we have to check once the sand is procured, we have to check the fineness modulus. It is a simple test. Take all the required sieves as per IS 383. Take as 500 to 600 gram of sand. Sieve through all the sieve sizes. Check what is the percentage passing. Sum of all divided by 100 will give us the fineness modulus. With this fineness modulus number, we can check what is the type of sand that we are using, whether it is fine sand, medium sand, or coarse sand. Then another important test that should be carried out on sand is silt content. Silt content should be less than 6. Maximum permitted is 6%. Take a beaker, fill it with sand, put the water, shake it rigorously so that allow it to settle for 24 hours. You can see a small sedimentation accumulated on top of the sand. The differential distance between initial and the final will give us what is the percentage. In order to accelerate the test faster, you can put a pinch of salt inside this and mix it rigorously so that we can get the result faster. Then the fine aggregate, it is proposed to have zone 3 type of sand, where the specific gravity will be around 2.6, and density of loose fine aggregate will be 1.46 gram per cc, and that of compacted will be 1.58 gram per cc. Silt content should be less than 6. Then the next important ingredient that goes to concrete is coarse aggregate. For applying concrete pavement, the coarse aggregate should be clean, hard, strong, dense, and non-porous. Any mica that is present in the aggregate should not be used. The aggregates that we are going to use for the production of concrete should be inert. It should not react with the cement. It comes in various shapes and sizes. The material ranges from fine particles to sand and larger coarse rock. Hard aggregates will give good strong concrete. It is always advisable to use aggregate having higher specific gravity. So these are the gradations proposed as per IS 383. So any size of aggregates that we are going to procure in the site should be checked to the requirement that of specified here. Generally, the specific gravity of coarse aggregate will be around 2.65. Then loose density will be 1.46 gram per cc, and compacted 1.63 gram per cc. The crushing value of 30%, impact of 30%, loss edges abrasion of 30%. These are the maximum limits. So these are some photographs of 40 down material, 20 down. It's a combination. So graded material of all types. So though we carry out concrete mix design as per 456 for the required water cement ratio and the slump requirement, it is important for us to check the gradation with respect to class 600 of Morth, where we are going to have the gradation requirements. This is the gradation requirement of the combined gradation for 40, 20, 12 mm as well as sand. So it is always better to follow Rothfutt method of mixed proportion, wherein individual gradations are marked on the graph sheet, and we can also analyze how these individual gradation of material behaving, whether it is single sized or different sizes or uniform. You can get clarity on this. Then the next important parameter that play in the design of concrete mixes is the admixture. As the requirement of slump for a PQC is around 25 plus or minus 10, since we are using a slip form paver, so it is all the more important to use a proper water retarding material like admixtures in order to improve the workability. So any admixtures that we use should fulfill to the requirement of 6925 and IS 9103. The maximum percentage of admixtures that can be used is up to 2% by weight of cement. Admixtures will improve the workability of concrete and extend the setting time. Studies shall be carried out to ascertain the compatibility of admixture and the durability and the strength. The type of admixture can be water retarding admixtures, accelerating admixtures, and air entrainment admixtures. When we are working with a very cold temperature zone, it is important for us to go with an air entrainment agent of around 6.5% to increase the durability. And the next parameter that gets into the concrete is the fibers. There will be initial shrinkage cracks since we are not going to provide any reinforcement in the PQC. So it is advisable that during the process of hardening, there will be some shrinkage cracks. These shrinkage cracks can be reduced using steel, polypropylene, polyethylene, and nylon fibers. This will reduce the plastic shrinkage, initial plastic shrinkage cracks, and increase the durability. The weight of fibers can be 0.2 to 0.6 by weight of mix. This is a dependent factor on the slump of concrete. So water that we use for concrete production should be that of potable. It should be clean. It should not have any acids, alkalines. These are the tests that should be carried out on the water that we use for concrete production. Then, as I mentioned, there is ISC also specifies the utilization of cementitious material by reducing the cement content. It can be fly ash up to 25%, GGBS, as well as silicon fibers. Silicon fibers are generally used around 3 to 10%, which to get high strength concrete. So this is a typical mixed design. You can see water 140 liters, cement 410 kgs, fine aggregate 760 kgs, 200 670, whereas admixtures 0.6 to 0.8, water cement ratio 0.34, polypropylene fibers with 900 grams. So, what are the field quality control tests that are to be carried out? As I told, it can be gradation on coarse aggregates, fine aggregates. Moisture content for fine aggregate is very important test that should be carried out before start of the work, so that any variation, very inherent moisture in the fine aggregate can be suitably reduced in water cement ratio, slump test, hand field test, and concrete cube test. So this is a slump cone test that should be carried out. So it will be filled in 3 different layers using 25 blows. It is subsidence of concrete against this thing. This will help us in understand the workability of concrete. So workability is an indicator in which the concrete can be produced, transported, placed, and compacted. So compaction factor is another parameter which gets into the design. Generally, for high workability, we are going to keep 0.9 as the compaction factor. So you can also carry out some hand field test on cement when we visit the site. It is something like a cement as well as for the aggregates. When we go to site, we can also take a small portion of sand from whatever we have procured. You can see if there are any stains on your hand. If there is no stains, which tell that the silt content is less. If there are some stains on your hand, definitely it gives a indication that the sand does have some clay content in it. Sedimentation test, which I just explained, could be another test that can be carried out on fine aggregates. And coming back to cement, you can have a hand-feel test even in the cement. Just if you put your hand inside the cement bag, you should feel cold if it is well within the usable period. Then take a pinch of cement and then rub between the fingers. You should not have any. You should get a smooth feeling between the fingers. Then another hand fill test can be, you can take a small quantity of cement, put it in the bucket of water, where the cement will float for a certain time and then it starts sinking. And it should not change its color. That's all the more important. So these are the concrete cubes that will be casted in the site and then later tested. So compression testing on cubes. So this is the acceptable limit. If we, within the project, we can also have our own standard deviation that can be obtained if we are not able to get a standard deviation for a single project. So acceptable criteria will be something like FCK +4. Suppose if our grade of concrete is M40, the acceptable requirement is 44 MPa. So any cubes that come into when you check the compression strength should yield 44 MPa. So this is another check that can be done while paving. This is the concrete paving and this is the paved concrete surface. We can stand behind the paver and using a probe we can check what is the thickness that we are laid. This is once again done once the concrete is laid. And coring can also be done once the concrete is set after 28 days after hardening, to assess the strength as well as the thickness of the core. Non-destructive tests are also available to assess the thickness as well as the placement of dowel bar. So the next parameter will be site and mix proportion, aggregate stack management, plant site setup calibration, then mix proportion and transportation of concrete. So it is when we are using a different sizes of aggregates, say 12 mm, 20 mm, sand, everything, it is all the more important to stack the aggregates in a different stack pile so that required percentage of materials could be used for production of 1 cubic meter of concrete. So proper stack piling technique can contribute to good concrete pavement. Sieve analysis shall be carried out at the start of the day's work. Moisture in the aggregate as well as in the sand can have an impact on your water cement ratio. So it is all the more important for you to check the moisture content before the start of the work. So this is a setup of a batch mixing plant. It is important to calibrate this batch mixing plant because most of the time we are working with volume basis, weight basis. So it is important to calibrate each equipment before being used for weighing. So this is the placing. In this, since we are going with a slump requirement of 35 mm, it is difficult for us to bring in a transit mixer and pour the concrete on top at the working site. So it is always better to bring the concrete in a dumpers or tippers and download it. Spreading. These are some of the photographs of how the arrangement will be done in the site. These are some photographs where we are using fixed form pavers. This is one such photograph showing the slip form paver, where you can see there is no forms provided on the site. Site shutters are provided. This is one such arrangement of fixed form paver, where you can see the needles for creating the vibrations, as well as you can see the drum for giving a better finish. You can, in case of slip-form paver, it is supported by agar for proper mixing of concrete. Then the placing and hand finishing. This operation shall minimize the surface irregularities that are obtained during the delay in production of concrete and placing of concrete. It so happens that it takes around 35 to 45 minutes for a transit mixer to come and deliver. So during that, a small bump is created from where the paver is stopped and where it starts moving. So using this operation, like tube floating, it is just to press this area using this equipment, which will be a 3-meter long floating edge, which will have a width of around 0.6 to 0.9 meters, so that undulations could be reduced. And next is texturing. Before the application of curing, it is important for us to do the texturing. The texturing will be done with a 3 mm wide groove for a depth of 3 to 4 mm. It can be manual, as you can see here, or it can be automated along with the paver. The width of the brush will be around 450 mm, and it is attached to a handle of 3-meter length, so that it can be easily done. The texture depth can be measured using a method called sand patch method. So this is a sand patch method to know the texture. You identify the known section in the site, just clean all the dirt, take a suitable volume of fine sand, and then spread across the designated area. And the quantity of sand utilized to the percentage of area spread will give us the texture depth. So these are some of the photographs with texturing. So you can see the curing being done using curing compound. So curing compound can be a resin-based or aluminum-based. It can be hardened. It gets hardened and forms a thin film on top of the concrete surface, so that there is no evaporation loss that has been that is there in the inherent concrete. And it is all the more important to understand and utilize those curing compound which will not have any reaction with the concrete. So groove cutting shall be carried out for both longitudinal as well as for transverse. The time for groove cutting is once again dependent on the strength of concrete that is achieved after 8 hours or 10 hours. So it is better that we examine the section or examine the stretch after 8 to 10 hours, and then take a call whether the groove cutting can be carried out or not. In all possibility, around 8 to 10 hours, the groove cutting should be started. And this is filling of groove with the joint filling compound. There are different types of joint filling compound. It can be polyethylene, it can be silica based, or it can be bitumen for that matter. It can be a pouring grade of concrete, or it can be a gun grade of sealant. So slump cone test carried out in the site. So some photographs, of course, this is that of white topping that we have done in Bangalore. So this is photographs. This is one road in Bangalore. Thank you, sir.
Thank you, sir. Thank you so much, sir.
Sir, thank you very much, sir.
Thank you, sir. Any questions I can take, sir?
Yeah, participant, do you have any question? You can just ask your question. That means you can just post your question in the chat box. Or if you want, you can just unmute your mic and you can ask directly to the sir. So the sir will clarify your doubts.
or you can write me a mail so that I can reply to that. No issue on that.
Yeah, that also I can do. I think feedback link will be given. Don't worry, will be Shivaraj will be posting it. You can write a feedback about the session. Thank you very much, sir. I'll find out if there is start is available and get back to you, sir. As you
Right,
said.
sir.
Okay.
Right, sir. Right, sir. Right.
After 2 o'clock, sir is giving presentation session. So I'll find out tomorrow. If anything is tomorrow, are you
No,
available?
I managed it here only. I managed it here in this session only. I think this is what I wanted to give.
Okay.
Then no issue.
Then no issue. Thank you.
Yeah.
Sir, I think one question has been posted in the chat box. Can you able to see, sir, or can I read?
One second.
Yeah, fine, sir.
What is the difference between asphalt and bitumen, right?
Yes, sir, that's the question.
Yeah, it is same. It is same. In US we call it as asphalt, whereas in bitumen, whereas in India we call it as bitumen. Shall we close, ma'am?
Yeah, sir, I think the questions is over, it seems. Further, is there any doubt? Means I think they will mail you, sir.
Yeah, please,
As
you
said.
can share my mail ID. So let them write to me. I will try to clarify.
Yeah, sir, we will share your mail ID.
Thanks a lot, sir. This is Raja.
Thank
Thank you.
Thank you, sir. Thank you, sir. Bye.
Thanks a lot, sir. Thank you.
Thanks. Bye.
So participant feedback links have been posted in the chat box. So kindly fill your feedback. And the last session, that is the session 3 for the day 4 STTP program, will be given by Mr. K. Jaishankar, sir. It's sharply start at 2 p.m. So after your lunch break, we will be meeting for the last session of the day at 2 p.m. So meanwhile, kindly fill your feedback and we will be meeting at 2.